In this video, I will talk about the easy system, which is different than the cis-trans system. So as I mentioned in the previous video, cis-trans, those two terms can be used only if there is a common group between the left and right carbons. So if you can find a common group between the left and right carbons, you can use the cis and trans. If not, then you cannot use the cis-trans. Now, first of all, regarding the easy system can be always used, whether you have a common group or you don't have a common group. For example, let's say start with the first compound here. Again, this carbon and this carbon. Try to find a common group between the left and right. Well, if I draw the hydrogens or if I don't draw them, those are the common groups. Or those are the common groups. No matter which you choose, the common groups are at opposite sides. See if this is a line which is passing through the double bond. The common groups are at opposite sides of the double bond. That's why this is a trans compound. Okay, whereas for example here, if I have two hydrogens, those will be on the same side. So this is cis. Again, if I try to find a common group between the left and right carbons here, so starting with this point here, the only common group which I can see is this and this. This is common between left and right. So those are on the same side. This is cis. Starting with this carbon here and this carbon here. Now, here is the problem. If I try to find a common group between the left and right carbons, I will not find any because I have a Br here, I don't have a Br on this side. I have a CH3 here, I don't have a CH3 on this side. So there is no common group between between the left and right carbons. That's why cis and trans cannot be used. So I cannot say if this compound is cis or this compound is trans. I have to use a different system, which we will learn later on in a few minutes. Finally, in the last one, again, we have a hydrogen here and a hydrogen here, and those are the common groups because the other ones are not similar. That's why this is similar to this. Those are at opposite sides, so this is trans. So again, this is a cis-trans system. Let's go back to the easy system. Easy system, as I said, can be always used, whether you have a common group or not. So if you have a common group, you can use cis-trans and easy. If you don't have a common group, you have to use easy only. You cannot use cis-trans anymore. Now, how do we know if the compound is E or Z? Step one, identify the highest priority group. And this is based on the priority groups rules which we learned in the stereochemistry chapter. So at each carbon, we have to identify the highest priority group. And the second step, you have to compare the relative positions of these two highest priority groups. Are they on the same side or opposite sides? If they are on the same side, then the compound will have Z geometry. If they are at opposite sides, then the compound will have an E geometry. For example, let's try to solve these examples here. Again, starting with this point here. Step one, identify the highest priority group at this carbon. So we have a Br and we have a CH3. Based on the priority rules, I know that Br is the highest priority group. So I'm done with the left side. Let's move to the right side. We have hydrogen and we have this ethyl group. Definitely the highest priority group is this group, which is the bigger. Now look at the groups which I circled. Those are at opposite sides. Again, if you are confused, just draw a line. You will see that those groups, one of them is above, one of them below the line. Since they are at opposite sides, I'm going to use this letter E, which states that those are at opposite sides. Let's take another example here. At this point here, this is the first branch. Your second branch is a hydrogen. Definitely we know that this is the highest priority group. Moving to the second carbon now. This one, we have this branch which is a CH3 and we have this whole branch. There is no need to just do the detailed method for determining priority. It's very clear that this is a CH3 group and this is a chain of carbons. So definitely this is more important, okay, or has higher priority. Again, look at the higher priority groups. You have one of them above the double bond, one of them below the double bond. So those are at opposite sides. Again, this is E. One more example, starting with this point here. The highest priority group is Br. On the other side, the highest priority group is chlorine. The highest priority groups are on the same side. They are both below the double bond. That's why this is Z. Now, in this system here, again, choosing the highest priority group, Br on the left side, and here we have, remember, we have an H and we have CH3. CH3 is the highest priority group, this is E. Now, someone might say, but we do have like a similar group. So we have a methyl here and a methyl here. Yes, that's fine. So this is Z, and this is also cis. So for this specific example, using cis trans is correct, and using EZ is correct. So both are correct. Whereas for this, and this, you can only use E and Z. You cannot use cis trans. Why? Because we don't have a common group. Okay? Now, just to let you know that it's not necessary if a compound is cis and we are trying to use the EZ system that's going to be Z. No, a cis compound can be Z or E. A trans compound can be also Z or E. Why? Those are two different systems. They are not the same. Okay? For example, let's say I gave you, for example, this one here. So if I gave you this compound and I said, is this cis or trans? You would say that starting with the common group. So we have a common group between left and right, and this common group is on the same side, so this is cis. However, if I said use the EZ system, then choosing the highest priority group on the right side is CH3. On the left side, it's Br. Now look at the highest priority groups. One of them is below the double bond, the other one is above the double bond. So this is E. So what I'm trying to say here is that cis and trans, E and Z, are different. A cis could be Z or E, and a trans could be Z or E. It's not necessary to have cis always being Z and trans always being E. Now, we have to pay attention that in naming, you have to include cis trans or EZ in naming. That's why when you try to name compounds and they say including geometry, you have to include cis trans or EZ. For example, starting with this compound, let's try to name. So this is 1, 2, 3, 4, 5, 6, 7. That's the longest chain, so that's heptene. The double bond starting from the left side will be at position 4, starting from the right side will be at positions 3, so this is the best number we can get for the double bond. And 4, this is 5. This is 5 methyl, 3 heptene. Now we have to assign the geometry cis or trans or E and Z if possible. First of all, is it possible to have cis trans or EZ? Yes. Why? Because this group or this carbon here is bonded to two different groups. So it has a hydrogen on this side and this methyl group on this side. So those are different. This group, which is the other double bonded carbon, has a hydrogen and another group. So we do have cis trans isomers. Is this cis or trans? The hydrogens are on the same side, so the common group is on the same side. This is cis. Now someone might say, okay, do we use cis trans or EZ? Both are correct unless we specify something else. If I'm using the cis trans system, this is going to be cis 5 methyl 3 heptene. If I'm using the EZ system, again, the highest priority group will be this and this, those are both below the double bond. So this is Z. So this is Z 5-methyl 3-heptene. Let's take one more example. 1, 2, 3, 4, 5, 6. This is hexene. Double bond from left or right, that's 3. Also, with respect to the branches, no matter where you start with, you are going to end up with 3 and 4. In this case, it doesn't really matter. 3,4-dimethyl 3-hexene. Now, is this cis, trans, or EZ? Again, common group. You can take this as a common group or the other one. And again, look at this. This is a line passing through the double bond. One of them is above, one of them is below, which means that this is trans. So trans 3,4-dimethyl 3-hexene. Or if you try to use the EZ system, it's going to be the same thing. So this is going to be E 3,4-dimethyl 3-hexene. Let's move on to this example. 1, 2, 3, 4, 5, 6. So this is hexene. The double bond is at position 3. Now, if I start counting from the left side, I will get 3, 4. If I start counting from the right side, I will also get 3, 4. However, counting from the left side will give the methyl position 3 and ethyl position 4. Whereas if I start counting from the right side, ethyl will get the smaller number. Since I'm getting smaller numbers, in this case alphabetical order rule, so 3 ethyl, 4 methyl, 3 hexene. Now, E and Z or cis trans, we cannot use neither E or Z or cis trans. Why? Because if you look at this carbon here, it's actually bonded to 2 similar groups. Since we have similar groups, we cannot use cis trans or EZ, so that's done. There's no geometry here. Finally, for this one, 1, 2, 3, 4, 5, 6, 7. This is heptene. The double bond, 1, 2, 3, 1, 2, 3, 4, definitely 3. Here, the branches will be at positions 3, 4, and 5. And they are all methyls. So this is 3, 4, 5 trimethyl 3-heptene. With respect to E and Z or cis trans, this carbon is bonded to 2 different groups. We have a methyl and ethyl. This carbon is bonded to 2 different groups. We have a methyl and this is a second butyl. So anyways, we have different groups, so we can use cis trans or EZ. Again, using the since we have a common group here, which is a CH3, we can still use the cis trans system. Those are at opposite sides, so this is trans. If you want to use the EZ system, you can also use it. So the highest priority group at this carbon here is actually this one, because it's bigger than the methyl. And the highest priority group at this carbon here is this whole thing, because it's bigger again than the methyl. Those groups are at opposite sides. So if you draw this line which passed through the double bond, those highest priority groups will be at opposite sides. So this is E 3,4,5 trimethyl 3-heptene. And this is how we name including geometry, cis trans, or EZ.